process. It's about theoretical knowledge related to fuel consumption and greenhouse gas emissions, reactive gases from ships, traffic that can be calculated based on fuel consumption, installed power on the ship by analyzing the overall picture of the ship's layout and the numbers of arrivals and departures for individual vessels that are estimated by performing calculations from below upwards. Actually, this is based on actual features and ship tracking. Then we have the use of available geographical data from a European Space Agency database on CO2, methane emissions, and nitrogen oxide emissions. There are monthly, years that can be inverse modeling. And finally, students should make a proposal for exercise uh, for vessels with the purpose of reducing the emission of harmful gases. The next lesson was case studies in sustainable maritime development in future tense, including artificial intelligence. This means analyzing real-world case studies, evaluating the impact of remote sensing in sustainable maritime projects, discuss the uh, discuss upcoming technologies and trends, theoretical exploration of artificial intelligence and machine learning in maritime sustainability. Then we have lessons about environmental monitoring and compliance, which includes theoretical framework for environmental monitoring using remote sensing and the role of remote sensing in maritime compliance and regulatory standards. Uh, the other part, of course, was exercises. This includes the setting up GIS, graphical information environment, and introduction to basics. When students set up the software, become familiar with functions, then they learn how to acquire and pre-process Sentinel-1, Sentinel-2 satellite data. Students learn how to access and download this data for Copernicus Open Access Hub. They import this data to their software. Also practice data pre-processing techniques, which is also important. We see in case example later the importance of pre-processing to enhance image. Analyzing sea surface and energy properties trends from satellite data is the next exercise when students analyze trends in sea surface properties using data from Sentinel, then try to identify anomalies and changes over time, and then real-world use cases which are presented by our co-partner from business. Then analyzing atmospheric compositions and air quality as an example of applications, which includes analysis of impact on maritime traffic to quality of air, etc. Then we have lessons about combining Sentinel-1, 2 data from multispectral analysis. When students learn about multispectral analysis, how to fuse or to extract some of data. And real-world case, our partner from business proposed plastic Iceland's detection as an example. Um, uh, Last but not least, lessons in exercises are about identifying environmental risks using remote sensing data, remote sensing data from maritime disaster management, and classification of satellite imagery. When students learn how to collect training and test data and perform simple binary and multi-classification of that data. Hence, the last slide about this curriculum of exercise is creating basic scripts for data manipulation. Then group projects where students apply what they are learned to real-world maritime challenges. And presenting, discussing, and evaluating the results of practical exercises. As you, as you are all aware, oil spills detections can be performed by different platforms. If you use satellites as platforms, sensors can be LIDAR, radar, infrared, optical, and uh, similar uh, platforms. There can be a microwave, including electromagnetic radiation, such as K-band, which is in NATO or EU classification as the X bands. So this is an example. Here is a case study of oil spill at sea. It's actually on coasts. When students can learn how to input the original image. This is here original image, and then can they transfer this color image during the different functions to enhance this image. This is
Prof, sorry very much for the interruption, but time is up. If you can please.
Yes, I'm almost finished. Don't worry, I take care. So this is enhanced images, and this is performed by Wavelength Transform in MATLAB. The problem was that most students didn't have a DSP course and don't know Wavelength Transform. This is examples of analysis with Wavelength Transform of original enhanced source images. And histograms can be used, for example, in spectral analysis to find or enhance oil spills. Finally, I can conclude that ESA insisted on more exercises. Our original proposals was 2 hours of lectures and 1 hour exercises per week, and they insisted on opposite 1 hour of lectures and 2 hour exercises. And as I didn't like MATLAB, which is usually an academy, yeah, so we have to choose open source geographic information system. They alternatively propose Sentinel 3 toolbox. And finally, there is also a problem with different origin of our students. There are some from management, from logistics, for marine engineering, and also from marine electrical engineering and IT technologies, which are more familiar with programming environments. So we have to adapt to everyone this course. So thank you. I sorry if I took a little bit more time. I prepared more. So thank you for your attention.
Thank you.
Do you have questions? Right.
Thank you very much, sir, and sorry again for the interruption. Thank you very much for the presentation. Anyone has any question? Seems like no one has any.